A mere 2,174 years ago, Death Valley was the site of a catastrophic explosion. To many, Death Valley within California, which often ranks among the world's hottest locations, is surprisingly also host to a singular active volcano. This volcano consists of a chain of 14 large and deep explosion craters in the ground, the largest of which measures a whopping half a mile long, 2,450 feet wide, and 722 feet deep. To understand the sheer power of the blast that formed the largest crater of the Ubehebe Craters volcano, I will compare it side by side to that of Sedan crater. Sedan crater formed as the result of an underground 104 kiloton nuclear blast in 1960. Yet, Ubehebe crater, which formed due to an explosion at a similar depth, is even larger than that massive aforementioned crater. Ubehebe Craters is classified as an active volcano and is listed by the U.S. Geological Survey specifically as a moderate threat volcano. If we zoom out from these craters ever so slightly, fault lines, and head just 3 miles to the west, there are a series of highly eroded monogenetic volcanic cones and their associated lava flows. Note how these several million-year-old features seemingly exist along 3 north to south trends, which in actuality represent now largely or completely inactive fault lines such as this feature here. Forming millions of years apart, formed due to the same geologic setting which could one day power a similar future eruption. These faults form due to the intersection of 2 tectonic provinces, the geologic setting basin and range, and the Walker Lane. The Walker Lane is a series of faults that accommodates the vast majority of the region's tectonic plate motion not accommodated by the San Andreas Fault. Meanwhile, the basin and range represents a broad area where the crust is slowly spreading apart, forming many fault lines. The created fault lines from this motion serve as weak spots in the crust that allow for magma to intrude into the crust on occasion and sometimes produce volcanic eruptions. At Ubehebe, this occurred through the Tin Mountain Fault. In approximately the year 150 BCE, a medium-sized batch of magma intruded into the crust, working its way up the aforementioned fault line and generating a swarm of earthquakes. While this was occurring, shallow magma ran underground to the west, transferring heat to underlying groundwater. This groundwater flashed to steam, causing it to expand in volume by a factor of 1,600 until the pressure became so great that it exploded and broke through overlying rock, generating larger ash plumes and multiple several hundred-foot wide Mar craters in the ground. Heavy rainfall subsequently filled one of these craters, causing repeated explosions within it to form the Little Hebe Tuff Cone. However, since these explosions blew off the top half of the existing cinder cone which had formed, collapsed material blocked its magma conduit. Thanks for watching.